Morning all, how are you? Thank you for attending my presentations. Like most IT guys, I don't like public speaking, but here I am, I have to do it. So I'm going to my supervisor, so before I can continue my work.
This is a friendly audience.
Yes. So you see the topic, if I try to make it easier to understand, it's about studying the impact of emotions on decision making under emergency situations. We use Bushfire as a representative case. So I've been supported by 3 wonderful supervisors, Steve, Ben, and Say. Say should be online as well. And that's my agenda for today's presentation. So I'll start with some introductions, a little bit of background, how I come up with the research questions, and decision-making framework under emergency, POMDP, something I didn't know until Ben introduced me about that, and why I think this is relevant useful for my research. VR experiments, something I'm always very excited about. Coming from IT background, you expect that, I like technology. And the next step for my research. So I got a bit of stats about Black Summer bushfire happened in Australia back in 2019 and 2020. Very horrific event. You can see the stats there. It created massive damage to the environment, properties, and people's life as well. And also lots of animals were killed and displaced by the fires as well. And there was a massive economic cost to the country. So events like that actually create some emergencies, which create challenging problem for people. Because what are you going to do in that kind of scenarios? I think from time to time we'll hear on news, people didn't follow the instructions or they act too late. So how do we define emergency? So there was a research talking about this as well, based on 3 components, talking about time pressure, the urgency of the situation, limited information, it's all uncertain, you don't know enough about what's going on, high stake, because at the end, talk about life and death situations, loss of properties, massive economic costs as well. Then what are challenges created by emergency? I think you can imagine if you put into that situation, very uncertain, highly stressful. It can be difficult for most people to take adequate actions because you've got urgency there, you might not have a lot of time. You need to think very quick and you need to be able to act at the same time as well. And it's always difficult as well because you might be, so you might be impacted by emotion as well because you've never been in that kind of situations before. You might be fear, panic, could be confused as well because you might be getting information from different sources, might be incomplete, and some might be misinformation as well. So why is important to understand this challenge? Because if we can understand the factors, what contribute to the panic or what hinder panic and other type of emotions involved in this kind of situation, we might have a chance to reduce casualties because we might be able to help people to make better decisions, help authority to develop better policies so people, can follow the order better, and also reduce, hopefully minimize the harm to properties and the environment as well. But the problem is, it's difficult, what is considered as a rational optimal behavior under emergency. And probably everyone will have a different definitions of that as well. So do we consider those emergency responder who have gone through lots of trainings to prepare facing that kind of situation so they can always choose what is considered as the rational and optimal actions? And they might have emotions, but they know how to control, suppress those things and just do it like any day's job. So it's very easy to say and done, of course, for most people, unless you've been to that situation, you've been through lots of training, you probably don't know what to do. So I want to say, like, even under normal circumstances, to make right decisions can be challenging sometimes as well. Even you got all the information, you got the time, but there are other things can happen. So the outcome might turn out to be the opposite. It's happened quite often in IT. We have to apply patches on, application or servers from time to time for cybersecurity reason. You read all the information supplied by the vendor, you apply it, and then the next thing is something happens, stop the thing's running. No difference like when you apply iOS patches to your iPhone, all of a sudden after you upgrade that, you think, oh, what's going on? The battery all of a sudden, drain out a lot quicker than before. So sometimes even you think you made a right decision with all the information and all the effort you put in, but the opposite might happen. So all of a sudden it can be a bad outcome. But there are things called luck in life. Sometimes you will make bad decisions, but something happened favor to their way for some reason, then all of a sudden that bad decision turned out to be a good outcome. So this is probably just talk about the challenge of making decisions, and imagine when someone is in emergency with limited information and all the other pressure and emotion, it will make it even more challenging to make a right decision. So here are the objectives of my research. I want to study the role of emotions in decision making under emergency, to investigate the impact of different levels of emergency on people's behavior and how different they are from rationally optimal, given that there's limited information in the emergency. And part of the research, because I will be using VR as a tool, so I also want to understand the strengths and limitations of VR as an experimental tool for investigating human behavior in emergency. So here are my objectives of my research. Then based on the objectives, I have these 3 research questions. Was people's observed behavior under different emergency levels defined, like back to the emergency definitions, defined by time, information, and state in an immersive virtual environment? And how do emotion and other factors that we don't know at this stage affect observed behavior under emergencies? And the last one is, what are the strengths and limitations of using VR technology to stimulate emergency situations? If I'm talking too fast, let me know. I slow down a bit. Yeah. So I start my research with a problem, a decision-making problem. So we have a house owner who's now facing a bushfire. It's all uncertain around the person. He must choose from a number of possible actions. Each one of them have a cost. And he's getting information, some sort of observations of the bushfire. It could be, the distance of the bushfires from his house, or the weather conditions from authorities or from other sources of information that he can find. And this house owner's objective is to minimize the expected cost of the decisions. Don't forget, I mentioned before, he's talking about life and death situation. He can lose his life, or he can lose his house.
Or both.
Or both, yeah. So why POMDP? I think at the beginning of my research, when I did a lot of readings, I look at different theories in economics and psychology. I didn't manage to find something I think I could use to answer my problem. And then Ben introduced me something called POMDP, which is stand for partially observable Markov decision process. First time when I Google it, okay, I come up with a number of those online tutorials, and I have a look. And they present a Pac-Man game. And for a lot of you will remember that game, because POMDP is a mathematical model used to model decision making under uncertainty, and used heavily in AI and robotics, and also operation research. So imagine like the person's like that working robots, sitting in your house, doesn't know where it is now, trying to move around to do the job. So this model allows the user to model something very complex as well, complex scenarios to manage states, different observations and uncertainties. So it's highly suitable for the problem that I'm trying to solve as well. So it helps you to find optimal decision-making policies. And the disadvantage that I found so far is mentioned about computational intensive, because there will be lots of calculations based on probabilities. So the more number of states you have, it's going to take more computation power. So some people say it's not suitable for those real-time applications when you have a lot of data coming in. So you probably need massive computing power for doing that. And while I'm doing finding relevant research work, I found 2 papers there. Someone has used POMDP to solve evacuation problem. But the problem they're trying to solve is more from the authority point of view, how to evacuate people. But my problem is from a different perspective, more from the first person perspective. The person is actually in the bushfire, how they're going to make decisions to get themselves out of that danger. So in POMDP, there are 7 components. So I list all the components on the left and some of the examples on the right. So we have a final set of states. So you can imagine we have the states about how far the bushfire is away from you, whether the house is burnt or it's not burnt, the status of the house. We have a set of action. You can stay and defend, or you can leave. When there's transitions in the model as well. It's talking about the transitions between states and action. So when you combine those 2 things, there's transition probabilities in that model. And we have reward that's based on the current states and the actions the agent takes. And that will give a reward, which can be potential lives and probabilities loss or save. And the agent had a set of observations, except nothing is 100% certain. So that's why there's observation function. So that's the O, that's the set of conditional observation probabilities. So that depends on the state and the action the agent just taken, and they get a different observation about the new state. And I'll explain more in the next slide how all these things join together. And we have a discount factor in the model, so it depends on whether you want to maximize the immediate reward more or the future rewards more. Yeah, so there's a discount factor that you can use in the model to manage that. So imagine now we have an agent at step 1, and this happens at every time step as well. So imagine we are at time step 1. We have an agent currently in the current state, which is represented as S here. But because this is partially observable in this model, so the agent may or may not know its current state. So it got its own belief state. It's some sort of probability distributions over the current state S, which is the agent's belief state. So the agent thinks he is currently in this state. He would choose a set of actions available in that state. that he thinks is the optimal action to take. So he chooses action, and based on the action and the current state, the agent will get a reward. And at the same time, the state will move to a new state as well. So now the agent is moved from the previous current state to a different state. And from this state, and also the action that the agent just taken, there's an observation given to the agent. So now the agent can get some information about what is possible, the possible state that he is at now. But of course, it's also a probability distribution. It's nothing certain as well. And based on the observation, the agent will update its belief state from B to the next one. Yeah, so now we get to the next state, and this will continue to the next step until we get to the end of the game, or whatever there's stopping rule to stop the agent. So if I can continue with just those states actions that I mentioned before. So here we have a simple POMDP example. We have 4 states. Bushfire is 10 kilometers away. Bushfire is 5 kilometers away. House burned, house not burned. And we have those 3 actions: stay and defend, leave. And the observation is about the locations of the fire with error, so it's not 100% as well. And we can define some sort of transition probabilities from one state move to another state. So you can see in the table, if we are currently in one of these 4 states, what's the probability that we transit to one of those 4 states? So we just put some numbers there, try to explain how it works. So from Bushfire 10 kilometers away, we think 80% of chance it will move, stay at where it is. 20% of chance it will move to 5 kilometers away. And then we move to the next line. So all this has to add up to 1 because there's between 0 to 1 the probability. Bushfire 5 kilometers away, so we don't think there's any chance it go back to 10 kilometers. 70% of chance it will stay where it is. 30% of chance the house will be burned because of that. So we do the same thing for houses burned and house not burned. And this is just for action state. So we continue to define another set of transition probabilities for action leave, because we don't think there's anything changed. So we're happy to leave all this the same as the other one. So we go to the next one for action stay and defend. So now because we think something has changed, and also because the agent is now taking action to defend his house, so we change the probability here, house burn and house not burn, to 50-50. We don't know because it's not that certain, because the agent is going to take some action to defend the house. So it shares the remaining 20%. Because until things actually happen, he's only had that probability to find out what might happen.
Can I just ask, the house is not burned?
Yeah.
What's the assumption about where the fire is? Is that you assuming that the fire is close to the house then, or
is that this one or this one?
The bottom one.
The bottom one. No, this we assume the house, the fire is far away from the house.
More than 10 kilometers.
Yeah,
okay.
or just can be only 10. Yeah, because of this one. Yeah. And we can have probability distributions of observations, like I mentioned before. So when the bushfire is 10 kilometers away, we think 20% chance the bushfire has arrived. 8% chance bushfire has not arrived because it's so far away. If the bushfire is 5 kilometers away, we think 60% chance bushfire has arrived. 40% chance bushfire has not arrived. If house is burnt, 9% chance bushfire arrived. Because there's nothing certain in this model, 10% chance bushfire has not arrived. And the opposite for house is not burnt.
Just a quick question there.
Yeah.
If the house is burned, is it because could be the 100% because the bushfire is right here. Right? That's why you are saying that. But how that can be less than 100%?
You're looking at the 0.9 and the 0.1.
Yeah.
How could it be 0.1? Like bushfire
Yeah,
not
true.
arrived. It must have arrived.
But this is an observations given to the agent. At that point, the agent is not 100% sure.
Okay.
Yeah.
Okay.
Yeah. So it's not saying that, like the previous diagram talk about the current state and the belief state. So the agent may or may not know the current state. So there will be time the agent is probably know exactly where it is, but it's not always the case. So that's why it's always uncertain in this model. Yeah. But you're correct because the house probably is already burned. But the belief state in the agent's mind might still be not 100% at the time based on the observations provided to him.
Yeah. I think we probably need to tease out those states a bit more. Yeah. So you could have fire 0 distance, house burns.
Yeah, probably more realistic if we get to that. Yeah.
Fire 0 distance, house saved, and then you to get this working, you'd have to add in things like fire extinguished, or the possibility of fire extinguished and then restarts again and moves backwards to being 10 kilometers away. So
yeah, I think this is still a very simple example that we have skipped many states that probably should be there for a more realistic scenario. And when we're having those state transitions, actually using something called transition matrix. So if you remember in the previous slide, we have if you can imagine, this is a 4x4 matrix. So we got the from and to from different states. So we have a matrix here with all those probabilities. And the model is actually using matrix transitions to work out the optimal solutions. So imagine we have this one, and then the initial states we think 100% is bushfire is 10 kilometers away. So in the first iteration, we have 1, 0, 0, 0 here, and then we multiply that and get another distributions. And then we'll just keep doing that for the next iteration until we have convergence for the solutions. That's where we find the equilibrium. That's when the model will tell us this is the optimal policy for the decision. So I didn't have time to implement that, with all those states and observations. This is based on a very well-known POMDP example called a tiger game. So someone facing similar situation, there's a tiger in front of him, behind 2 doors, either on the left or on the right. The person can listen. It's not 100% correct every time, so there's a 15% chance it can be wrong. So he might hear the tigers on the left, but 15% chance might be actually on the right. So I just rename some of those parameters and run it using a POMDP package in R. And this is what the model thinks, in terms of optimal decisions. So it generates a policy graph and tells you the initial belief. So the agent should start at this point. That's what the model thinks. And the action to take is to gather information, so to listen. Because the models has put into 50% of chance of the tigers on the left and the right. So it's still uncertain. So if the person thinks bushfire is not arrived, then you can see all these arrows is the observation. And the person can follow, just say that the person thinks observation of bushfire is not arrived, he follow this arrow and get to this state. And this state, the best action is to gather information to listen more. And now get another observation, bushfire not arrived, so the action recommend to take is to stay. But on the other hand, if the observations the agent told was bushfire arrived, so it will take this arrow and get onto this one. And this stage, the best action is to gather more informations, and then got another observations, bushfire arrived, and now the action is to leave. So this model is represent what probably considered as more rational optimal decisions, just based on all those information probability distributions applied to it. And this is I would consider as the first part of my research to sort out the POMDP model before I can look at the interesting part of using VR. So we think in a highly immersive environment that should trigger people's emotion a lot more than in the normal circumstances. And VR is probably a perfect tool for doing that because it gives realism. It got the ability to place someone into a virtual environment at the same time to make people feel like they're actually there. Something probably, if you never experienced, I would recommend that you probably, there are many places this day you can try those VR games. You will have better understanding because a lot of things you probably have to try. Yeah, so by using that technologies, we can study decision making under Bushfire more from a first-person experience. So we place a subject wearing a VR headset and put them into a Bushfire scenario. Looks like real one. If we all done properly. And good things about using VR is once you got those VR scenes done, whether you do encoding or whether you use some sort of modelers or 360 cameras, you can reuse them. So every time it will be the exact same fire condition if you want it. Yeah. And it's not possible for me to run a field experiment, as we can understand. There will be safety concern if we have to put someone running around in a real bushfire. We can't guarantee the person will be able to come out safely as well. And VR headset is getting better and better these days. Multiple sense stimulations. I mean, you got the audio, got the visual, you got the gloves. If you program all those things well, people can, put a hand on objects. They can move things around, not just to walk around. So they can actually be placed in a house. If they choose to leave, they can walk to the front door and open it and walk out. So those things are possible, in today's technology. So as I mentioned before, so it will be two parts. So first, I need to use POMDP as a benchmark tool to represent rational agents to choosing optimal decisions. And when I did the laboratory experiment using VR headset, it's more about testing hypotheses with emotions. So we want to understand by comparing the results between those two things, why there's a deviations, what caused that, emotions, and what else for all those scenarios and treatments we're going to do. So I'm still learning all those things at the moment. So I can say, of course, there's some challenges as well. Those probabilities and states, all those things probably I still need to, finalize and make sure that they are all logical as well. Even though I'm coming from a computer science background, used to do a lot of programming, but never done any programming in VR. So there's still something I need to learn. Only good thing is where I work and my agency, actually we teach those things as well. I didn't know that until last week. It's just one of the lecturers in the area mentioned to me, Wing, I heard you're doing a research degree in AI. I said, no, not AI, doing VR. Oh, okay, we can teach those things. Well, we can help you, Do you want to enroll in our class? So I might be able to get a bit of help to fast track that because there are multiple options for those playing games. There's a gaming engine called Unity, used a lot for doing game development. You can also use open source modeler called Blender 3D, if you ever heard of that one. And also in Adobe, they have something called Adobe Substances, also allow people to create a virtual environment as well. And also I was told, which I found that before as well, 360 cameras. There's some cameras you can use that you can take 360 movies, and then there's software, you can convert that into a virtual environment, and then you can play that with your headset. So there are multiple ways, that I still need to explore as well. And if we want to make the VR experiment a bit more interesting, apart from audio, visual, and the touch capabilities that provide by the headset, imagine that we put someone in a room with the headset. When it's getting closer, or when the observation is getting closer to the house, we turn on a few more heaters around the person, or burning something, I don't know what it is, but making some sort of smoky flavor and smell in the room to, to stimulate more emotions, the person feel like, okay, the fire is coming to me, Yeah, so then more things can be done. Of course, we'll have to make sure that it's done properly with approval as well. Make sure no one will get harmed by those things.
There could be semantics
Yes.
issues to deal with.
Yeah. And also, using those VR headsets is good, but we have to follow something called 15-minute rule based on lots of research. There might be some sort of dangers if you put someone in that kind of environment for too long. I have a colleague at work mentioned to me he played a VR game with his headset for over half an hour, and then he went somewhere and he was driving on the road. He felt like that he was still in that virtual environment while he's actually driving. So you can see it does have an impact on the brain. So that's why it's recommended not putting someone for longer than 15 minutes. So when we design the experiment, all these things had to fit with all those parameters, Yeah. And the next slide is more or less is just repeat, the things I just mentioned, things that I need to do. Hopefully I get to the end, get the results I can share with you, And it's my presentation. And thank you.
Thank you, Link, for the presentation.
Yeah.
So, is it possible to jump back to your questions, your research questions at the beginning? So I think it would be helpful to include an additional research question at the start, which is all of the work that you showed us, right? It's about how do people, what would be an optimal response to a bushfire in different contexts? So you're doing a lot of work on that. So that could be a standalone piece of work that has value in itself, separately from these other questions. So I suggest that you have that as another question.
Okay.
And then a comment on the Markov chain modeling.
Yeah.
It's obviously very powerful, and the great strength of it is it's dynamic, right? Yeah. You can handle uncertainty over multiple periods. That's the advantage. You mentioned one disadvantage, but another disadvantage is that in order to be tractable, the decision problem has to be quite simplified. Like, and you showed in your little example, obviously that was a very simplified example, but even if you make it more complicated, you can never reach a level of realism that it would be you'd expect in a real world problem. So you have a bit of a challenge that it will be hard to tell whether a deviation from what someone's doing in your VR experience and what's coming out of the Markov chain, how much of that difference is just due to the simplifications in the Markov chain model, right? So I'm not saying don't do it, I'm just saying it's something to be conscious of. And so to help with that, maybe in addition to doing a Markov chain model, you could also build a sort of in parallel a simulation model, which is a dynamic simulation model. Doesn't optimize, but allows you to simulate for a specific management, a specific decision in a specific context. And you can then change, and it would use very similar information to the Markov chain model, right? It's basically similar, but it could be more fine-grained. More, instead of just having the fire 0 and 5 and 10 kilometres away, it could be any distance, you know, much more easily to represent that. And so you could get some other advantages that you don't have in the Markov model, while also losing the optimization, right? So there's a trade-off. But if you did them both, you could compare the two and see what you could learn from the two and how similar they were.
Thank you.
Okay.
You didn't mention who your target population will be that will be participating. Have you given that any thought? And then would you be asking any survey questions as to their previous and prior experience with bushfires, like and how that is likely to impact their decisions?
Yeah, I haven't get to that point yet, but I did think about that. Probably for the VR experiment, we're looking for someone probably not a professional, you know, emergency responders, definitely not firefighters or those who are always involved in that kind of situations, because a lot of them probably has been trained, they know what to do. And from one of the research papers I found before as well, they also exclude those people. So they have a survey first to ask those people if they would choose to leave straight away. They don't want to include those people as well, because probably not much they can study from those people, because pretty much at the starting point of the experiment, they would disappear straight away. Yeah.
So I'm just thinking, like, I wouldn't see a lot of point in you asking somebody who lives in the metro area.
Yeah.
I don't think it's something that they consider frequently or realistic. So perhaps country, small town.
Peri-urban.
Yeah, right. The people in the hills, for example.
Yeah. Thank you. Yeah.
Can you, of course, you are in the stage of developing further, but I'm wondering about your second research question, particularly the emotion. How you are thinking to measure emotion? Because it has to be somehow factored in. How do emotion and other factors affect observed behavior, right? So how do we measure emotion in those kind of situations? I don't know the answer, but I'm raising the question.
Yeah. That's why we're trying to understand the difference between the POMDP model, and of course, it might not necessarily represent a real optimal decisions. So the deviations might be more than just emotion and also other things as well. So I will think after experiment that we'll have to some sort of survey for people to report their experience about that as well, whether they think some sort of emotion, whether they feel fear, and also when we do the VR experiment, don't forget the good things about those equipment is actually doing tracking of the body, the movement, the eye movement, and other things as well. Of course, if I got the approval of the subjects, that we probably can record that as well. We can go back to watch how people react as well. Yeah.
You could record, I mean, with the ethics issue is a real issue here.
Yeah.
But assuming you could get ethics approval, you could record heartbeats,
Yes.
blood pressure.
Yeah, there's all those things they can measure.
Temperature, you know, all sorts of measures of stress.
I've read some of those from other research papers. Yeah.
Might find out about standard sort of psychological questions that measure different
emotional
impulsiveness, for instance.
Actually, I participated in a psych study that was all about emotions for like a year, and they're called the feel study at EEL. So you could probably find their survey in a paper that they published, because it was a barrage of questions of emotions. So
it's, I think it's got different characteristics. Some people are impulsive, and other things, and that can be probably measured by a standard questionnaire bank.
Yeah.
So then you can see how those different types of people respond to the VR experiment. My impulsive daughter left immediately. It was a bushfire. So, that doesn't prove anything.
But you could also observe potentially deviations between a stated preference and a revealed preference. People might say that they have certain emotions, but then you monitor them and their heart is completely unaffected.
I have a comment similar to Dave's second comment, but on the other side of what you're doing. So thinking about this VR exercise, I think there's a lot of opportunities for really systematic error, or systematic noise to come into what you're recording. So a lot of research on AR and VR for market research, because everyone really wants to do AR and VR in market research, says you should be really careful because you'll maybe say, we're thinking about redeveloping this parkland in all these different ways, and they'll maybe have a building on it, and it'll have like a purple molding on the building, like around a door, and then it'll just like influence public opinion massively because they see this like little purple accent on a building when it's not even what they're measuring. So I'm wondering if you can also develop something really simple to compare to the VR exercise too. Again, this might just be more burden and more work, but could you develop a really simple standard lab exercise that also looks at the same purpose? Like, could you essentially do this bushfire exercise and what we typically see in these ag econ experiments, where can you basically like make an Oregon Trail style game of there's a fire and you just keep updating people, and there's maybe a payoff function where they're going to make $10 or lose it all at the end of the day. Just I'm thinking there's a lot that can go wrong with the VR stuff, where someone might be less experienced with it, or they might just notice certain things that aren't part of the experiment or the design of your scenario, and just kind of make stuff explode.
Yeah. Okay.
Is that life like?
What's that?
Is that life?
Yeah.
People being distracted by.
Yeah. The problem is like when you're like making an immersive environment, it's just like these little inconsequential things can really set off in a systematic way where like women might just notice something that men don't notice, and then all of a sudden you'll say, oh, women were way less emotionally responsive, but it was actually just that the color of the flames was setting people, you know.
It is life, but it's about affecting your inference about results is the thing.
Originally, the plan that Wing had was to sort of compare, you know, people's reactions through just text, and then have pictures, and then have VR. And then we did away with the first two because it was obvious that the amount of information that was going to be accessible or available with VR was going to be much greater and much more realistic, and that with the standard, it would be so inadequate actually that it was, in the end, we did away with it. It was like a foregone conclusion. You wouldn't be able to generate the kind of information that is important in that kind of situation, and therefore you would not observe, you could not observe the kind of behaviors that you're interested in. So that was,
So emotional responses.
By the way, I just wanted to correct a question, since we're at it, by Ram, right? It's not actually the correct question to ask in this study, because we're not psychologists, so we're not trying to understand emotions or measure emotions. That's not part of it. It could be emotions, that's a working hypothesis. It could be other factors. What we're interested in is measuring the deviations, whatever the factors are. So you have, once you have your POMDP, you have strategies, as it's called, the policies and strategies of behavior, the dynamic, which are optimized relative to whatever objective function you have decided it is, and you use that a bit, use that as a benchmark or a measuring rod, whatever you want to call it, and then observe behaviors. And then presumably the behaviors are not going to be optimal in that sense, and you then are going to vary the situations, the scenarios, the amount of urgency, the amount of the cost, to see how that works and how that affects that deviation. But in fact, what is actually creating a deviation is not part of this study. I would say that.
That would be useful to have, though.
Wouldn't
Wouldn't you like to know what was causing the deviation?
It's a whole different. The reason we're not doing it, it's the whole new PhD. It's not something you can do on the back of an envelope. It's complicated.
Okay, if it's really not that, if you're really not doing that, then I think you need to take emotion out of the question.
Yeah.
But I would question whether that's the best strategy, personally.
See, just I'm thinking, when you think about deviation, I know the question is perhaps completely wrong, but when you think about deviation, you need a reference level.
Yes.
How do you establish the reference level
It's
of
the
emotion?
POMDP solution.
That gives the reference level of emotion?
Yeah.
No,
Well,
not of emotion, of the
No,
strategy.
of just purely the rationally optimal strategy given the information, which is uncertain, right? Given the information available. And of course, the suggestion that Dave said that it's a simplified setting Then you have a problem with the interpretation of the results. So what is due to simple, and so having someone else made that suggestion as well, maybe purpose having another tool, simulation, is a good idea. We haven't actually worked on that yet, so we'll see.
I just wonder how long, what's your duration for your bushfire experience? Whether it's just a single day or over a period of days, and then if your participants have the option to come back. So my father decided to leave, but being the man that he is, snuck back in on all the back roads to go back to the property regularly, and they would go back. So, yeah, sort of what duration are you thinking for your fire experience?
10 days, yeah, we talked about that before, yeah.
For the POMDP,
Yeah.
15 minutes for the VR, actually.
Yeah.
Sorry, I was just thinking, just something really, really useful that could come out of this. Not necessarily focusing on the emotion side, but on the information side, is that if you ran a simulation and gave slightly different information on your model, you will come up possibly with a suggestion for a device or some tool that people could have in their homes which would give them that information at the right time. That could actually be a really helpful thing to run simulations on and see if it made a difference to the optimal decision making. That's not looking at the emotion side, that's just looking at your POMDP modelling. And I wondered if you took that further, then you actually could just possibly look at using case studies instead of the VR. So going over past situations with all the information that you had, and then run your model, a more complicated one probably, and then put different information in to see if that person would act differently or the model would behave differently given different information. Because I think that the emotion part, it definitely does come into it, but at the same time, everyone has different value systems, and that's their personal value system. I read a story about a lady who went back in a bushfire to let her horses out, and then she died, but the horses, I believe, were saved. And I'm not sure that she would see that if she was alive and ask the question, is that rational? Well, she might say yes. So she would repeat that. That's her value system, which we would never know. But I think that running that model on the actual live situations to try and see if they had different information at different times, could the decision making be better? I think that could be really, really useful.
I think that's a really good point about the different objectives. That you can't really talk about what's the optimal without assuming an objective, and so that means you don't really know what's optimal for any individual.
I mean,
Yes, absolutely.
Yeah.
Actually, I think emotion is really a placeholder right now. It's a placeholder. We just to fix ideas and allow Wing to think through, but it could be just a very small part of what's at stake. Probably not. Probably as important, but definitely not the whole story. We know that.
But if you have the reason I'm coming back to that though, whether it's emotion or something else, or misperceptions or something, if you have some knowledge of what the factors are that cause people to behave in a non-rational way, that could be life-saving to know that, because that helps you to devise responses to that. I think that's where the interest in this research would be.
I agree, but I'm not sure that we are actually, Ben or Said or myself, or that we are tooled up to do this kind of now. We would have to bring in someone from psychology. I think we just don't have the tools to work on that.
Maybe to do that, bring someone in.
Well, maybe we will. Maybe we will.
The talk about sort of completely different sort of idea is that coming out of the Black Saturday bushfires, there are many videos that people took of approaching fires and commentating their thoughts as the fire was approaching, and in some cases talking about what they are going to do or what they've already done. Some of them are terrifying.
Actually, that's a very good.
And so that would reveal a lot of things about their thought process and their emotions and all sorts of stuff, actually.
I think there are also online questions that are related to this issue. Alternatively, maybe can you unmute yourself and ask, or just shall I read it?
I think it's related to what just Dave was saying. A person's decision and also perception depends on what's happening around them. So I was just wondering how that comes into the research. How is that taken care of? Because if you are in a certain situation, what you are going to do or what you think is happening will depend on what your neighbors and so on are doing. So is the model how does it account for this, or is that something that's just ignored? Did you hear my question?
Yes.
Yeah. I think this probably is something that can be modeled in observation as well, because we can certainly have others appear in the bushfire as well as one of the observations. So that house owner I was talking about probably can hear the noise from the next house, or depends on how we want to, simulate that perception, And this is something I thought about as well. Even in VR, that might be a possibility, because some of the VR research I read before, you can have virtual human, these days in those virtual environments. And I know Unity has working with OpenAI as well, so you might have a virtual human probably can behave on its own without you programming as well, Yeah, so it's possible, but we haven't thought to get to that stage at least. Haven't get to that at this stage, because I think we're trying to get the simple things done first before we add more complexity to the model. Yeah.
Just related question from Michael. Michael, can you unmute or just read it?
Yeah, if you can hear me.
Yeah.
I think I know, but wondering whether you're connected with the Centre for the Advancement of Research on Emotion at UWA. I think the answer you're going to give me is no, because they seem to be backtracking away from emotion, but I think you should do. I think it's really difficult to think how you're going to be able to answer these research questions without fully engaging with emotion and how that drives people and understanding it. So I think that just hook up or start the conversation with the Colin MacLeod group and just get insights from them.
Okay. There's two voices on there.
Maybe. Last question, maybe from Julian, if you have one. That I see multiple questions. And can you go ahead?
Oh, do you want me to put my question to first? It's very simple. I was just wondering where you got the discount rate from. That's all.
We haven't get that at this stage, I'll tell you that. So it's in the model, something we need to explore as well. Yeah. Yeah, it could be a personal thing as well, because each individual might see it differently as well. What is the immediate reward, the future rewards, what's more important, and like I said, what is considered as optimal decision making as well in that scenario.
But it's another of research. How does discount rates affected by in this sort of context?
Yeah.
This sort of decision compared to sort of normal consumption type decision making. Could be very different.
And it produces very, yes, I agree, and it produces very different results, I suspect, depending on different people and different discount rates. So it could dominate some of the aspects of the model. That's all I was flagging up.
Yeah, that's a good point.
Thank you.
Just in the funds for a project, looks like really ambitious. Is there any partnership or getting support from the brand?
I think I did see next year name $6,500 just yesterday or before yesterday. I'm pretty sure, so I'll check that. But if that's the case, we can do a few things with that.
Yeah.
Even just recruiting people for an hour.
Yeah, that's part of the experimental.
Okay.
Yeah.
Okay. Thank you, Wink, for coming and.
Thank you.